revenue function normally begins at the origin. So if you do not make any products, then there is no revenue, right? If you don't sell any products, there is no revenue, there is no income. So therefore, the revenue function begins at the origin, and it will proceed upwards to the right. If you plot the graph, it will proceed upward to the right, increasing based on the selling price of the product as well as the production quantities. And when the revenue line or function crosses the total cost line, that is the break-even point. Okay, so when the revenue line intersect with the total cost line, you will see that intersection point is actually the break-even point. Because break-even point is the point where the revenue equals to the total cost. Okay, I'll explain. So if you want to understand better, it can be explained using this graph. Right, so the x-axis is the production quantities or production volume. How many number of products that you're making. The y-axis is the money, is the dollar. It could be revenue, it could be cost. Right, so fixed cost is this line. Let's say your fixed cost is $200. So this fixed cost is a straight line. It's a straight horizontal line. It's fixed. Okay, it does not depend on the production volume. Whether you're making 0 units or 1,000 units, the fixed cost is the same. And variable cost will look something like this. Variable cost will be a straight line starting from the origin, and then it will go up. Okay, so variable costs, of course, if you don't make any products, there is no variable cost involved. As the number of products increase, the variable cost will increase. So you will also have a straight line, variable cost. Now, when you add up the variable cost line with the total cost line, if you add up these two lines in green color, if you add up the variable cost line and the fixed cost line, we'll get the total cost line, this line in blue color. Right, common sense, right? If you add this green line with this horizontal line, basically we are just shifting up the line. So we will get this total cost line here. So this is the total cost line. So total cost equals to the variable cost plus the fixed cost. Right, and if we plot the revenue line or the revenue function, remember revenue begins at the origin. If you don't sell any product, there is no revenue. And revenue will increase depending on how many number of products that you produce and how many number of products that you sell. So this red color line will be your revenue line. Okay, and this point here, this intersection point here, this point is called the break-even point. So this point is where the total cost equals to the total revenue. So at this point, basically, you just break even. You're not making any profit. You're not making any loss. Okay, what it means is that whatever income that you got back, you manage to recover back the cost or the expenses that you have spent. Okay, that's the meaning. So at this point, if you project it down, okay, we will get the even point in terms of quantities. Okay, in terms of the production quantities. So here we know, okay, this is the production quantity that we have to set or that we have to produce in order to break even. Okay, and from there, a production manager can plan their capacity. Okay, so let's look at formulas. How can we get the break-even point? Okay, before formula, you must understand the assumption that we make in break-even. First assumption is cost and revenues are linear functions. As you see, all of them are straight lines. Okay, so that is the first assumption that you have to make. We have to assume cost and revenues are linear. But generally, this may not be the case in the real world. In the real world, cost can fluctuate, revenue can also fluctuate, and the fluctuation could be random. Okay, so in real world, you may not get a straight line, you may get certain fluctuation. But for analysis purpose, for mathematical modeling purpose, we assume that all these are straight lines. Second assumption, we assume that we know the cost and the revenue exactly. Okay, but in real life, sometimes we do not know the cost value or the revenue value exactly. Because there are so many type of costs involved, and sometimes manager will just estimate. They will just estimate the cost value and the revenue value rather than putting in the exact value. So when we do this break-even analysis, we just have to assume that the cost and revenue are known exactly. So it means we know the exact values. And the third assumption that we make is time value of money is often ignored. Right? So money has a value, and the value of the money changes with time, just like currency rate, currency exchange rate. So the money has a time value, it can change with time, but then in break-even analysis, we assume that the time value of the money is constant. We assume that it is constant. We ignore any time value changes in the money. So these are the assumptions that we make in break-even analysis. So let's look at some formulas to calculate the break-even point. Right? Okay, first thing, make sure you know what is P. P is the price per unit product. Okay, so P is actually the revenue, the revenue or the selling price per unit product. X is the number of units produced. So if you use P times X, you will get the total revenue. P multiplied with X, you get the total revenue. Okay, so it's written here, PX is total revenue. Capital X stands for fixed cost. Fixed cost. Capital V stands for variable cost per unit product. So if we use V multiplied with X, if V multiplied with X, we get the total variable cost. Right? So imagine again, graph like this. So we want to find the break-even point. So the break-even point occurs when the total revenue equals to the total cost. Right? So it means that we can write total revenue equals to the total cost. Total revenue equals total cost. So what is total revenue? Total revenue is P times X. Okay, and equals to the total cost. Total cost is comprising or consisting of two elements. Total cost is equals to the fixed cost F plus total variable cost. Total variable cost is equals to V, which is the variable cost per unit, times X. X is the number of units products produced. Right, so if we rearrange this, we can calculate X. So X is just equals to F divided by P minus V. Very simple, right? So in textbook, X is known as BEPX. BEPX is the break-even point in units. Units means production quantity or production volume. Okay, so remember this formula because in exam we will not give you. Remember that break-even points in units is equals to F divided by P minus V. Now, next, you can also calculate BEP dollar. BEP dollar. BEP dollar is the break-even point in dollars. Let's go back to the graph. Look at the graph. At this point, we get the break-even point. Okay, but if we project to the y-axis, we will also get the break-even point in dollars. Right, so how to calculate this point? So this point is known as BEP dollar. BEP dollar. Okay, and this is BEPX. So BEP dollar is just equals to the slope of this line, slope of the revenue line times BEPX, right? So it's just equals to something like y equals to m times x. So y is BEP dollar equals to m. M is the slope of this line, which is actually the P, yeah? Right? The selling price per unit is actually the slope of the line. So BEP dollar equals to P times BEPX, which is the X value. I hope you understand. So the way to calculate BEP dollar break-even point in dollars is equals to the break-even point in units in production quantity times P. P is the price per unit or the slope of the revenue line, right? So BEPX we have calculated, it is equals to this, right? If you look at the previous slide, BEPX is this F per P minus V, yeah? So F per P minus V times P, yeah? So if we rearrange that, you will get this, right? If you divide the numerator with P, if you divide the denominator with P, you get this. And if we rearrange this, we will get this. Okay, F divided by P divided by P is 1, and then V divided by P. Yeah? So this is another formula that you have to remember. BP in dollar equals to F divided by 1 minus V divided by P. And if the question asks you to calculate profit, I think that is very simple. You know, everyone knows how to calculate profit. Profit is just total revenue minus total cost. Right? So total revenue is PX. Total cost is the fixed cost plus the variable cost. So if you rearrange the formula, you get this. So let's look at one simple example. So let's say given fixed cost is $10,000, and then you're given direct labor cost, and you know direct labor cost is a variable cost, because it says per unit. So the total labor cost depends on the number of units being produced. So all the variable costs normally has dollar per unit. Once you see dollar per unit, those are variable costs. So direct labor cost is given as $1.5 per unit. Material cost is also a variable cost. It's given as 0.75 cent per unit. And selling price is given as $4 per unit. So with this, we can calculate break-even point in dollars. So break-even point in dollars is calculated using this formula I've shown you just now. So what is F? F is fixed cost, so 10,000. And then 1 minus variable cost. So in this case, variable cost consists of two elements, right? It's the labor cost and the material cost. So it means 1.5 plus 0.75. So you get 2.25. So 2.25 divided by the P, yeah? P is the selling price, $4. If you calculate, you get this. So this is the break-even point in dollars. So it means what? It means if you have a product with all these details, so what is the price that you should sell your product in order for you to break even? So this is the answer. This is the price that you should sell your product if you want to break even. Right? If you sell less than this value, you will incur losses. If you sell more than this value, you will get profit. That's the meaning. Okay, and we can also calculate the break-even point in quantities, in production quantities. So it's just equals to this formula, F divided by P minus V. Fixed cost is 10,000. Okay, P is the selling price, 4. And then minus variable cost. Variable cost is 1.5 plus 0.75 is 2.25. So you will get this 5,714. So this is the break-even point. So it means this is the production quantity that you have to produce if you want to break even. If you produce less than this, again, you suffer losses. If you produce more than this, then you will get profit. Okay, so I think I don't have to explain this. This is just the graphical representation of this example. So break-even point is here, 5,714. And the break-even point in dollars is somewhere here. It's about what, 22,000 over, right? Yeah, 22,857. Okay, so remember this is the region where you suffer losses. This is the region where you get profit. Right, let's move on to break-even analysis for multiple products. Just now we look at a single product. Okay, but you know companies always sell multiple products. Right, so how to do break-even analysis if we have multiple cases or multiple products? So these are the formula. Break-even point in dollars, BEP dollar, if you have multiple product, is equals to F divided by 1 minus VI per PI times WI, and then you sum up this term. So what is F? F is fixed cost, so it's fixed. VI is the variable cost per unit for each product. Okay, we have an I here. I here means for each product. So VI is the variable cost per 1 unit of the product for each type of product. P is the selling price for each unit for each product. Okay, and what is WI? WI here is the weightage. You see W, right? W is like the weightage, the weight. Okay, so this weight is calculated as the percentage of each product in terms of the total dollar sales. Okay, so it means how many percent each product constitute in terms of the total dollar sales. So that percentage represents weightage. Okay, it's like a weight, weightage. Right, so what you do is you just multiply this term with weightage and then you sum up. Right, so if you look at this formula again, it's very similar to the single product formula, right? The single product formula have this. Okay, but if you have multiple product, you just have to multiply with W, the weightage, and then you sum up the term here. Right, so I hope that is understandable. It's easy to understand. So let's look at one example. Right, so let's say there's a shop selling 3 types of products. The shop sells sandwich, drinks, as well as baked potato. So given the fixed cost of the shop is 3,000 per month. So be very careful. It says per month. So later you may have to change to per year or per day or per hour. Depends on the question. So you have to be very careful with the units. It's given per month. Now, sandwich selling price is $5 per unit, and the cost of making the sandwich is $3 per unit. The drink selling price is $1.50 per unit, okay, per drink. The production cost is 50 cents per drink, and same for potato. Selling price is 2, the cost is 1. And also given this information, annual forecast sales units. So this is the annual forecast production quantities. So you see, it gives you annual, means per year. So later you may have to convert all the costs to per year. So instead of 3,000 per month, you have to convert to the total cost per year. Now, why the question give this forecast sales quantity? Why? Because later you have to use this to calculate W, the weightage. Okay, so how do we solve this? Quite easy. Create a table like this. Alright, so given selling price P, so this selling price here is P, okay, given the production cost is actually the V, variable cost. So you must know, price is the P, and this cost here is the V. One is the selling price, the other is the variable cost. So first thing you have to do is create a column, calculate V divided by P. Okay, why do we need this? Because you see the formula, we have V divided by P, right? So you create a column, calculate V divided by P. And then you create another column, calculate 1 minus V divided by P. Okay, so create a column, calculate V divided by P. So V divided by P for sandwich is 3 divided by 5, you get 0.6. For drink is 0.5 divided by 1.5, you get 0.33. For baked potato is 1 divided by 2, you get 0.5. After that, as I said, create another column, calculate 1 minus V divided by P. Okay, so 1 minus 0.6, you get 0.4. 1 minus 0.33, you get 0.67. 1 minus 0.5, you get 0.5. Right? Okay, and then create another column, calculate the annual forecast sales in dollars. Okay, given are the values in quantities. So we have to know the annual forecast sales in dollars. How to get the annual forecast sales in dollars? You multiply the quantity with the selling price. Okay, so 9,000 times 5, you get 45,000. 9,000 multiplied with 1.5, you get 13,500. 7,000 multiplied with 2, you get 14,000. So this is the annual forecast sales in terms of dollars. And then what you do is find the total. Why we have to find the total? Because later we have to find the percentage. Once you know the total, we can create another column. We can calculate the percentage of the sales. Now, this percentage of the sale, I already said before, this is equals to the weightage, W. Right? So how to calculate the percentage of the weightage? It's just the sales value divided by the total. So 45,000 divided by 72,500, you get 0.621. And then 13,500 divided by the total, you get 0.186. Then 14,000 divided by 72,500, you get 0.193. Okay, and if you total up, it must be equals to 1, because this is percentage. So the total weightage has to be equals to 1. And the last thing you have to do is create another column, calculate this. Okay, so what is the last column for? The last column is to calculate 1 minus V divided by P times W. Right? So it means you use this column, multiply with this column. Right? So 0.4 times 0.621, you get this. 0.67 times 0.186, you get this. 0.5 times 0.193, you get this. Okay? So basically, I'm calculating this term over here. And don't forget to sum up. You have to sum up this term. And therefore, you have to calculate the total. So this total here is the summation, which is 0.470. So once you got this, then I can calculate BEPY using the formula given. BEPY or dollar. So BEPY in dollar equals to that formula there that you have seen just now. So it's equals to this. Okay, BEP break-even point in dollars equals to this formula. So F is given as 3,000 per month, right? And since we are working with per year, because we calculated the annual forecast sales dollars, right? So we have to change the fixed cost to per year. Okay, so 3,000 times 12, we change it to per year, and then you divide by this term. This term has already been calculated, which is 0.470. So 0.47. So if you calculate, you will get this. So this is the break-even point in dollars. Here we call it BEP dollar or BEPY, because it's the y-axis. Right, so this is the BEP in dollars per year, per year. Okay, so if the question asks you what should be the break-even point in dollars each day, okay, what is the break-even point in dollars for every day? Then you have to divide this value with the total number of days per year, right? So this is the total number of working days per year. The question gives us 312 days. So this value is normally given in the question. So you just divide by the number of days per year, you get this. Okay, and now let's say the question asks you to calculate what is the break-even point for sandwich per day. Okay, so if the question asks how many units of sandwich that you should sell, that the company, that the shop should sell every day in order to break even. So how do you calculate that? I repeat, the question is how many sandwich the shop should sell every day in order to break even. So you can calculate it like this. You use 245.5. You times with the weightage. Okay, weightage is 0.621. You times the weightage and then divide back with the selling price. Right, as I explained before, BEP in dollar equals to BEP X. Okay, multiply with the slope, which is the selling price. Okay, so now you are asked to find the break-even point for sandwich every day. So you use the BEP in dollar, which is 245.5, but then you have to times back with the weightage first. Okay, because if you times the weightage, then it will reflect the true quantity of the sales. So 245.5 times the weightage, and then you divide back with P. Selling price of sandwich is $5. So if you do that, you get this answer, 31 sandwich each day. So this is the number of sandwich that the shop should sell in order to break even. Okay, so any question? So this is the end of the chapter already. Now, if you have the textbook, you will see that the textbook discuss one or two more techniques, but those techniques will not be covered in this course because you will learn them later in other courses. Okay, because one of the techniques that talk about net present value, so that technique you will learn it in engineering economy. And another technique talks about expected value. So this one you will learn in operation research. Okay, so I think operation research you will take next semester. Engineering economy you will take it in the final semester. So is there any question?
Doctor, I have a question.
Okay.
Usually we use the break-even point before or after we obtain the data, like after the sale or before the sale.
Normally you need to have the data first. Okay, you need to have the data first. For example, the production cost, which is the variable cost, the fixed cost, okay, and also the revenue. So you need to know that first before you can know the break even. Okay, and this one sales here is actually not the actual sales. This is the forecasted sales. Okay, so it means we forecast them first so that we can know the break even. So I hope that answer your question. So it means we don't do the thing first, then only we calculate the break even. Right? We forecast the thing in advance. Okay, and you have to get the data on the revenue, the cost, and with that you can set the break even point. So does that answer your question?
Yes, Doctor.
Okay, I think you're confused with the sales here. Okay, maybe you think that sales must happen first. No, this is the forecast sales. It's not the actual sales. Okay, so if no question, then I would like you to do this. Okay, I just want to make sure everyone understand. So this is a tutorial question. Okay, I'll give you 15 to 20 minutes for you to solve these two questions. And then after that, I will discuss the answer with you. Okay, I don't have the answer. I've done it, but I don't have the answer, but I will discuss the working steps with you. And for those who have solved it, you can share your answer in e-learning later, not now. Okay, later when you have solved it, you can solve the answers. You can share the answers, or you can share the answers in e-learning. So 20 minutes start from now. So everyone, please take out your pen, your pencil, piece of paper, calculator. Please work on these two questions. Okay, later I will ask you guys to tell me the answer. Right, it's already 12 noon, huh? So I think we can discuss the answers. The first question, huh? Marty has a business packaging software in the US. Okay, the business annual fixed cost is 10,000, huh? So fixed cost is 10,000. So F equals to 10,000. What else is given? Direct labor cost is $3.50 per package. And material cost is $4.50 per package. So variable cost is equals to 3.5 plus 4.5 per package. So this will give us 8 per package. And selling price is $12.50 per package. So P is equals to 12.50 per package. Right, so what is the break-even point in dollars and units? Very simple, right? If you got this correct, it's just a matter of putting them into the equation. So calculate BEP dollar. So this is equals to F, which is 10,000, divided by 1 minus V. V is 8 per P, divided by P, which is 12.5. So anyone has calculated this? Can you share the answer? 27.7. 27.7. You sure it's 27.7? It's 10,000, 10,000 divided by something. Okay. It's not 27.7, it's 27777, Okay, I think it's something like this, 27777. So I think it's easy, and then to calculate the EPX, so this is the break-even point in terms of production volume or production quantity. So this is equals to F 10,000 divided by P minus V, right? Divided by P minus V, which is 12.5 minus 8. Right, so this will give us, okay, anyone want to share the answer? 2222. Okay, I think it's correct. 2222 units. Okay, units of package, packages. So any questions for question 1? Any queries? Okay, no queries. I see a lot of response in the chat, so everyone knows how to do. Okay, that's good. Okay, but the problem is it's the same person that responds most of the time, Okay, the rest should start responding, rather than keeping quiet, so that I know that you understand and you're participating in the class, So the next question. Okay, there's a guy called John. John has been asked to determine whether the $22.50 cost per ticket for a community dinner theater will allow the group to achieve break-even and whether the 175 seating capacity is adequate. Right, so there's a community dinner theater and the ticket price is sold at price of $22.50 per ticket. So the question asks whether this price is it enough to break even, and also the dinner theater will allocate 175 seats. So you also have to find out whether this 175 seats, which is the break-even point in quantity, whether this is enough or not to break even. So given what? Given the cost for each performance of a 10 performance run. So what is this? This is the variable cost, right? or fixed cost. The cost for each performance of a 10 performance run is 2,500. So this is fixed cost, but fixed cost per performance, because it says for each performance. So it's 2,500. The facility rental cost for all the entire 10 performances is 10,000. So this is the fixed cost, another fixed cost. Drinks and parking are extra charges and have their own selling price and variable cost as shown below. Right, so even ticket price, selling price is $22.50. Cost is $10.50. Drinks, parking are also given. Now, drinks, parking sometimes are optional, not compulsory, right? So it means not every participant or not every attendant will buy drinks. And parking also, if you carpool, for example, if you carpool, you share the car, then you don't need the parking. But ticket is compulsory, right? Everyone that enters the dinner will need a ticket. Okay, so therefore the question asks you whether this ticket price is it enough to break even, and if the dinner theater only have 175 seats, will it be enough to break even? So calculate BEP dollar and BPX to justify your answer. Right, so let's start. Do it. Okay, let's bring this down. So fixed cost F is equals to 10,000 plus 2005 times 10 right? Because it's given for 10 performances. So we calculate it for 10 performances, 10,000 and then plus 2005. So 2005 is for each performance, so you have to multiply with 10. So for this you will get 35,000. Okay, correct. And variable costs, things like that, you have to work on the tables. So remember the method that I teach you, this is where we have multiple products, right? So for multiple products, first you have to create a column to calculate V divided by P, right? So insert a column on the right. Now, if you still don't understand, selling price is P, I hope you understand already. Cost here is the variable cost, which is V, So create another column, calculate V divided by P, V divided by P. Okay, so 10.5 divided by 22.5. Okay, let me look at my answer. 12.5. I think the textbook also have this. If you have the textbook, then you can see the answer as well. 10.5 divided by 22.5, you get 0.467. And then 1.75 divided by 5, you get 0.350. And 2 divided by 5, you get 0.4. So this is V divided by P, and then create another column, calculate 1 minus V divided by P. 1 minus V divided by P. So 1 minus 0.467, you get 0.533. 1 minus 0.350, you get 0.650. And 1 minus 0.4, you get 0.6. Okay? Any questions so far? It's just like what I've shown you here. And then next thing is get the total. Right, so the total of this is 450. Okay, so this is the sales quantity. You have to calculate the sales dollars. So add another column, calculate the sales in dollars. Right, so 175 multiplied with 22.5, this will give us 3938, right? And then 175 multiplied with 5, you will get 875. 100 multiplied with 5, you get 500. Right? Calculate the total. You total this up, you get 5313. Yeah. Okay, and then next thing, create another column to calculate W. Okay, W is actually the percentage, yeah, percentage of sales for each category here, for each product here. Yeah? So 3938 divided by 5313, you will get 0.741. 875 divided by 5313, get 0.165. And 500 divided by the total equals 0.094. And as I said before, the summation of the weightage must be equals to 1. Percentage must be 100%. So must be 1. And once we have done this, create another column, calculate 1 minus V divided by P times the weightage. So it's basically this column multiplied with this column. So you multiply them, you should get 0.395, 0.107, 0.056. Total of the column is 0.558. Okay, I hope it's correct. Okay, give me a moment. Let me answer my phone. Okay, sorry for that. Let's continue. So to calculate BEP dollar, this is equals to fixed cost, which is 35,000 divided by what? Divided by this total, right? 0.558, right? So 0.558. So what is the answer? Anyone can give me? 62724. Okay, correct, 62724. Okay, good. 62724. So is this adequate? Is this enough to break even? Yes or no? Yes or no? The break-even point in dollars for a total of 10 performances is 62,724 dollars. So is this amount of dollars enough to break even? Okay, no. Why? Why no? Okay, how to see yes or no? You must, okay, correct. You must look at this total. For total sales in dollars, at the moment is 5313. That is for one performance. This is for one performance because it's given sales quantity per performance. So for one performance is 5313. So for 10 performance is 5313 times 10. So you should get 5313 30. So at the moment, the sales that you're getting back is only 53130. Okay, if you have 175 seating capacity and if your cost per ticket is 22.5, to break even, we need this. So it means at the current situation, we still cannot break even. So we are still suffering losses. So that's the answer, not enough to break even. And the question also asks you to calculate BEPX. So what is BEPX? BEPX, to check whether this 175 seating capacity is enough or not. So what should we do? Okay, we take 62724 times back with the weightage first, which is 0.741. Then divide by 10, because you want to get the value for a single performance. So divide by 10. And then we divide with the selling price, right? So this whole thing we divide again with the selling price. Selling price is 22.5. Okay, understand? 62724, which is the total sales to break even, times back with the weightage 0.741, divide by 10 because we want to get the value for a single performance. And then based on the formulas, we divide by P. P is 22.5. Right, so you calculate this, you should get, anyone has calculated the answer? 206.75, 206.57, sorry. So it means to break even, you need a seating capacity of 206.57. Okay, so it means the current seating capacity of 175 is not enough to break even. Right, so I hope everyone understand. Okay, I see all the comments in the chat. Okay, good. It shows that you understand. So, as you know, this subject is not so difficult. It's not so difficult. It's actually one of the easiest subject in IE. Uh, I think that there are other easier subjects. Okay, you have taken work design before, right? So I think work design is also very easy. This subject, production planning and control, is not difficult. Also, it's relatively easy. The difficult subject will be operation research, simulation, and so forth. All right, so we are done with the tutorial. Whoever is hardworking, please share this answer in the e-learning so that those who are absent can know the answer. Okay, I would now like to discuss with you test one. Okay, so test one is coming, so we have to set the date. So I've decided to do test one on 27th April. Is that okay for all of you? I will do it during the class time. So there is no reason to say that you cannot attend the test. Yeah, because I'm doing it during the class hours, during the class time on Wednesday from 11 to 1. And the topics covered will only be until here. Okay, fair enough. So it means only 3 chapters will be covered. Chapter 1, Introduction. Chapter 2, Forecasting. Chapter 3, Capacity Planning. Any objection from the students? Okay, I've seen respond. Okay, okay, okay. So it's okay then. Okay, so fix. So it's fixed, So test one will be on 27 April, Wednesday during class time. So it means from 11
Doctor, we
until,
may have a test in that day.
uh, okay, but then different time,
According to
right?
the schedule, maybe we will have applied numerical method in 27.
Okay, but then different time, right? As I said, different time. So different time shouldn't be a reason lah. Okay, different time, there's no clash, it shouldn't be a problem lah. Uh, provided that, this subject is also easy, it's not so difficult. Maybe you have to spend more time in numerical methods. But not everyone is taking numerical methods, huh? Everyone taking numerical methods? Some say yes, some say no, huh? Okay, taking, but okay with same date. So I assume okay, huh? I assume okay. Because if I do it on Monday, then I don't know. Monday will be exhaustive, will be tiring for some of you. Okay, I think in the morning better. You will be more energetic to do the test during the morning rather than on Monday at 4 to 5. International student, no problem, huh? I hope if you're in the Middle East, you have to wake up earlier, huh? Wake up earlier and then start the test. Okay, Abdurrahman, already say okay, doctor, then. Okay, then I consider decided, fixed, and I will remind you again next week. Right, so any other question? If not, we can end the class for today. Don't forget to start your group project. I need to remind you again because on the 21st of April, you have to submit a brief proposal. Every group has to submit a brief proposal and upload it to the e-learning system. Huh? So from there, I need to know which is your case company, what are you doing, what problem are you solving, your objective, okay, and the team members. So no question then, we'll stop here. Right, so okay, so see you guys next week. So bye-bye. Okay, bye.